Quick question. What comes next in this sequence? The answer is of course Sunday. That's today. Anyways, our first video was released 4 days after approximate pi day. That is of course if we use DDMM format and the days and months are slash separated, because writing the date like this or like this won't make any sense. But 22/7 is the approximation you would find in many of our childhood textbooks as an approximation of pi, which is more close to the actual value than 3.14, our original pi day. But Albert Einstein was born on our original pi day. What's so special about 22nd July other than that it is 1 day and 1 month after summer solstice? So many of us celebrate Pi Day on our original 14th of March, but this got me thinking. Let's take a look at the classic pi equals 4 proof, and later we'll prove that the proof is wrong. Take a square, say of length 1 unit, and a circle inside it such that the circle touches all the sides of the square. Now if I start walking from A to B to C to D and back to A, I will have covered the distance of 4 units. That is to say the perimeter is 4. And the perimeter or the circumference of the circle is pi from the formula circumference equals pi times diameter. Now let's make some diversions in the square path. We can see that WD and VD are the same length, so going from V to D to W will cover the same distance as going from V to small d to W. Same goes for these diversions. So if we take this path or this path, it doesn't matter, we'll cover the same distance. Now let's make few more diversions, still we'll have to cover the same distance. Add few more and a few more, do that infinite times and suddenly our square becomes a circle. But the distance we need to travel will be the same, won't it? If it is the same, that is 4, and the circumference is pi, then pi equals 4. So where did we go wrong? Let's take a simple example just for the explanation purpose. Consider this right angle triangle. The distance from A to C via B is 2 and the distance from A to C directly is root 2. Now from the midpoint of the sides make the same diversions and we'll get the result root 2 equals 2. Okay, let's take one step at a time. Let's divide these sides in halves. So the length of each segment will be half and there are 4 of them. So total distance is 4 multiplied by half, which is 2. Divide further and we'll have 8 segments, each of length 1/4. Again the total length is 8 multiplied by 1/4 equals 2. If we do that infinite times, we'll have infinite segments each of length 0, making the total length 0 into infinity. Here comes the problem. On multiplying 0 and infinity, we get an indeterminate quantity. An indeterminate quantity is the one which has no fixed value. The value can be anything. Let's try some. For convenience, let's express 0 times infinity as 0 times 1 upon 0. That is 0 upon 0. Let's try this division. What should we multiply 0 with to get the remainder 0? Let's try 0. 0 times 0 is 0 and we get remainder 0. Hey, it works. So 0 by 0 is 0. Now let's try 10. Hey, this works too. Let's try square root of 10. That works too. Let's try complex number. It is also an answer. In fact, try any number and it satisfies our condition. So the answer to 0 divided by 0 can be anything. In case of our triangle, the answer is square root of 2. How do we know that? By Pythagoras theorem, of course. In case of our circle problem, it is pi, and our problem is solved. Even in the integration, we need to be careful about what elements we are adding up. For example, let's say we want to find the surface area of a sphere. It is similar to what we did with the perimeter of a circle, just rotate it along one of its diagonal and we take these elements from the inside rather than outside. As we go ahead with this integral, we can see that in the end we get something like this. Compare it with the actual formula for the surface area and notice that if we substitute pi as 4 in the bracket, we'll get the desired result. Also notice that only one of these pi's need to be adjusted. You know, the one which came from the careless integration. But why stop with pi equals 4? Let's prove that each and every number is the same. Consider infinity. It can be written as 1 over 0. Multiply and divide by -1 and we get -1 upon 0, which can be written as minus infinity. So a raised to infinity equals a raised to minus infinity, where a is any number, and therefore 0 equals infinity. Now since minus infinity and infinity are equal and infinity is equal to 0, we get minus infinity equal to 0. And since all the numbers lie between minus infinity and they are both equal to 0, all the numbers equal to 0. Obviously there is something wrong here. Let's see if you can figure it out. Thank you for watching this video. Please like, share and subscribe to CPU Classroom.